Hi, today we're going to decompose some algebraic fractions into partial fractions. We've got the first example here and a second example that's a little bit trickier. So let's start with the first example. I've already commenced the decomposition into partial fractions. You'll notice I've got two terms here on the right hand side and I'm able to factorise the denominator on the left hand side. 2x squared plus x minus 6 factorises into the factors 2x minus 3 and x plus 2. So I'm going to decompose this algebraic fraction into two partial fractions. Okay, so to be able to add these fractions together on the right hand side, I need to cross multiply the denominators. So I'm going to get a goes into x plus 2 and b goes into 2x minus 3. Okay, all over 2x minus 3, x plus 2. Okay, so this step implies that ax, expanding that numerator, plus 2a plus 2bx minus 3b, that should be equal to the numerator of the left-hand side, which is 4x minus 13. Okay, so we need to equate the coefficients here. So we've got going to get two simultaneous equations. We're going to get a plus 2b equals 4, equating the coefficients of the x's, and then equating the constant terms, we're going to get 2a minus 3b, that equals negative 13. Okay, so we have two simultaneous equations here, 1 and 2, and solving those, any algebraic method you like, or using your CAS, you will find that you will get a equals negative 2, and b equals 3. Okay, so we can rewrite now the algebraic fraction decomposed into two partial fractions, and that will be equal to negative 2 on 2x minus 3 plus 3 over x plus 2. So that's our fraction decomposed into partial fractions. Okay, that example is a fairly straightforward one. We're going to go to example 2 now, which is a little bit more involved. You'll notice example 2 is x to the power of 5 plus 2 divided by x squared minus 1. Okay, the order of the x term in the numerator is a lot higher than the order of the x term in the denominator. So the first step there we need to do is a polynomial long division. Okay, so we're going to divide the denominator into the numerator, and we're going to get a quotient and a remainder. So we're going to divide that into, we're going to divide x squared minus 1 into x to the power of 5 plus 2. Okay, so first of all, x squared goes into x to the power of 5, x cubed times. Okay, and then multiplying x cubed through here, we're going to get x to the power of 5 minus x cubed as the remainder of that division. Okay, so let's subtract these terms from each other, these two expressions from each other. We're going to get 2, well, x to the power of 5 minus x to the power of 5, that works out to be 0, so that's okay. And 2, take away negative x to the power of 3 is going to give us x to the power of 3 plus 2 as a remainder. Okay, so let's have a look. Does our denominator go into this remainder? Yes, it does. It goes, x squared goes into x cubed x times. So let's multiply that quotient back into the divisor. So we're going to get x cubed minus x. Okay, subtracting these, x cubed minus x cubed, that's pretty much 0. And 2 take away negative x is going to give us x plus 2. Okay, let's see if we can keep on going. Well, x squared does not go into x, so that's the end of our division. So what do we have here? We've actually started to take apart this algebraic fraction into its quotient and remainder. So x, this can be broken up. There's the quotient there, x cubed plus x. And the remainder is x plus 2. And of course, that is a fraction. Okay, so this now is starting to break up the algebraic fraction into components, into different terms, and you'll notice this one here can be broken up, this term here can be broken up into a partial fraction in a similar way to the way we did example A. Alright, so let's just divide this up here, and let's have a look here what we can do. It's pretty straightforward, x plus 2. That denominator is a pretty easy one to factorise. You should all be familiar with that one. It's the difference of squares. So this one is going to decompose into x plus 1. Okay, so what have we got here? So again, we do the cross multiplication. We're going to get a x minus 1 plus b x plus 1. That should equal x plus 2. Okay, so we're going to end up with a simultaneous equation again. So we're going to get ax, expanding that right hand side, minus a plus bx plus b equals x plus 2. Okay, equating these, a plus b, that's got to equal 1, the coefficients of x's, and minus a plus b, the constant terms, e should equal to 2. Let me make that equal sign look a little bit more like an equal sign. Equal to 2. Okay, so we have two simultaneous equations again, 1 and 2, and these ones are pretty easy to solve. You can see here, if we just eliminate a, we will get 2b equals 3, and therefore b's got to be equal to 3 on 2. And having a look at this, if b is equal to 3 on 2, a must be equal to -1/2 from equation 1. Okay, so let's decompose this whole right-hand side now. So the whole right-hand side is equal to x cubed plus x minus 1 on 2. That's the half. X plus 1. Plus 3 on 2 for b, x minus 1. And there we have it. We've decomposed that algebraic fraction into its components.